Hi, in this short lecture, I am going to talk about bubble sort. As you can see, binary search is much faster than the sequential search. But in order to use a binary search, the list must be sorted. Sorting is the process of placing elements from the collection in some kind of order, maybe ascending, maybe descending. There are many sorting algorithms out there that they have developed and analyzed. We will look at a few of them, the simple one. Um, I just want to say sorting a large number of items can take a substantial amount of computing resources. Like searching, the efficiency of a sorting algorithm is related to the number of items being processed. And to analyze a sorting process, we have to look at, for example, in order to sort a collection, it would be necessary to have some systematic way to compare values to see if they are out of order. The total number of comparison will be the most common way to measure the sort procedure. Uh, when the values are not in the correct position with respect to one another, it may be necessary to exchange them, and the exchange is very costly. So the total number of exchanges will also be important to evaluate the overall efficiency of the algorithm. And the first sorting algorithm we're going to look at is bubble sort. With bubble sort, it will make multiple passes through a list. It will compare the adjacent item, the one that next to each other, and exchange them if they are out of order. So what's happening is each pass through the list, it will place the next largest value in a proper location. In essence, each item bubble up to the location where it belongs. For example, let's look at a example here. If this is the list that we start with, so we will compare, for example, 54 and 26. We see that 54 bigger than 26, so these two get swapped. Now we compare 54 and 93. 54 and 93, they are in order, relatively speaking. And then we compare the next two, 93 to 17. 93 to 17, they are not in order, so they are swapped, as you can see here. And then we compare the next two, 93 and 77, they're not in order, so they swap. Now we compare 93 and 31, they're not in order, so 31 here, and 93 compared to 44, and they are not in order. So 44, 93 and 44 swap, and now 93 compared to 55, they're not in order. So 50, they swap, and 55 here, 93 here. Now compared to 20, they're not in order, and swap. At the end, you see that 93 is in the proper location. In this case, it's the end of the list. And then the next pass, we will only compare from the first to the second to the last list, because we know 93 is in the right place. So this is only one pass. In the one pass, I have one number in the right position. And then the next pass, I do the same thing. The next largest number will be in the proper location. Next pass, I do the same thing, and so forth, until I only have one item left in the list, which will be in the proper location. Why we study bubble sort? Because bubble sort algorithm is very simple to write. I have two nested loop. The pass number, I go from the length of the list minus one. In other words, I go from like for example 10, 9, 8, all the way to, in this case, 1. I go from bigger to lower. For I in range pass num, so it will go from for I in range 0, 1, all the way to 9 in this case. If there's a 10 item in the list, I just making an example here. And a sub list sub I bigger than a sub list sub I plus 1, meaning if the current number bigger than the adjacent number, then swap it. This is the way to swap. Notice that there's a 3 operation. I had to save the a list sub I to temporary variable, and then swap these two. A list sub I equal to a list sub I plus 1, and a list sub I plus 1 equal to 10. And then look at the bubble sort. I will just run this to show you the list is sorted, and I can also run with the debugger to show you few steps. And let's go to console. Right, actually not much on the console. Let's go to debugger here. So here the A list, and each step of the way are the two adjacent A list sub I bigger than the next one, the adjacent one. Yep, swap them, and then I keep doing this until you will see the 93 will get put in the right place. I just want to show you the same step that we see earlier with the bubble sort. In Python, you can actually swap two variables using tuple. We talked about tuple many weeks ago, and one of the tuple way is we can swap two variables. So using Python, bubble sort really just 4 lines of code. As you can see, the simplicity of bubble sort. It's really that 4 lines of code, and using the Python, we're swapping data. A list sub I, comma, a list sub I plus 1 is equal to a list sub I plus 1, comma, a list sub I. I just swap the two adjacent elements, just like that. So what about the efficiency? Well, you see there is a nested loop. And what we talk about with the nested loop? With the nested loop, the big old running time is n squared, quadratic. Bubble sort is often considered the most inefficient sorting method. This is the worst of the worst. But bubble sort, there one little advantage of bubble sort is because it goes through the whole list. If it goes through the whole list and there's no a change take place, what do you know about the list? That's right, the list is sorted. So bubble sort can detect the list is sorted in the middle. Maybe the list is mostly sorted already. After a couple passes, the list is sorted, so you do not need to keep going. So in this case, I can create a change variable and set it to true initially. So the outer while loop, now using the while loop instead of for loop, I check the exchange, and every time going inside the while loop, I will set the exchange to false. And here, inside the for loop, if there's an exchange take place, I will set the exchange to true. So what that really means is, if I go through the entire for loop with no exchange take place, then the exchange will be false, and the while loop will terminate. And then I can get out early. And in this case, if I pass a sorted list, after one pass, the bubble sort will terminate. So in this case, this would be like an ON, the best case scenario. If I give you a sorted list, I don't know if the list is sorted. Keep in mind, the bubble sort doesn't know the list is sorted already. It check and see that no exchange, And so you know the list is sorted now. Before you were quadratic, had to run through every iteration. Now I can actually stop earlier if I detect no change, mean the list has been sorted. So we will do this exercise in class. Show the intermediate passes through the following list being sorted by bubble sort. You can try that at home before we come to the class. What I mean is, given this list, after one pass, what would be the list look like? After two passes, what would the list look like? In the early example, we only do one pass. So now we'll go through the whole entire list until the list is sorted. Try out at home, and I will reveal the answer in class.